Alright, third video on separable differential equations. Some may not even get to this video if the first two videos were helpful enough, but let's do a couple more examples, round this out, and then we'll move on to logistical growth patterns, which is, if I'm not mistaken, 9.4. Now, remember that y prime, first of all, needs to become that, okay? And we need to think of y squared plus 1 as one entity, so that when you separate this stuff onto each particular side, you get this. Okay, wait a second so you can see it. Basically, I just divided by y squared plus 1 multiplied by dx and divided by root 1 minus x squared. And this ought to look familiar because this is going to give me arctan. This is going to give me arcsine. Okay, so I have arctan y is equal to arcsine x plus c. And of course, when I isolate y, I'm going to get the tangent of arcsine x plus c. Ruh-roh. Okay, well that might actually look a little bit daunting, but that's not really that big of a deal because remember, that's the general solution. I'm looking for the particular solution, so I'm going to go ahead and plug in 0 for both my input and my output. When is the arcsine, what is the arcsine of 0? Well, that's 0, right? And when is tangent of c equal to 0? Well, when c is equal to 0, okay? So basically, that means that I have y is equal to the tangent of arcsine of x. Now, here's the thing. That, as far as I'm concerned, it's a legal way to leave things, but it's not the best way to leave things, because I happen to know that there is a relationship that is implied by that, okay? Now remember, this stands for an angle measurement. We'll call it alpha, and if alpha has a sine of x over 1, opposite over hypotenuse, it has an adjacent of 1 minus x squared. And the tangent of that particular one is opposite over adjacent. That is the particular solution. That is the initial value solution for that particular problem. Now, if you wanted to, could you take the derivative of that just to test it in order to try to get back to your y prime? And the answer is yes. And I'm not going to walk through it here, but it actually does work, okay? And you would have to, you'd have to go up and actually take this y and square it and add 1 in order to get this y squared plus 1 in terms of x. But from there, it actually would be relatively straightforward. Okay, well, let's go ahead and just do a couple more straightforward ones. Let's do another trig one since we haven't done a whole lot of trig. We just did inverse trig, but whatever. So we have 1 over secant squared y. Now that ought to be extremely easy, and let's go ahead and work that. We know that dy dx is a ratio, and therefore a ratio equal to a ratio is a proportion. In order to satisfy the proportion, let's go ahead and cross multiply. Okay, we know that we can go ahead and integrate both sides. That gives me tangent y is equal to x plus c, or y is equal to arctan x plus c. And you're just going to have to ask your teacher whether she wants it in explicit form or whether implicitly is just as good, because I would actually leave it right here. The implicit is going to be much easier to actually work with. Okay. Well, let's do another one. How about dy dx, let me move that up for everybody, is equal to 3e to the x minus y. And remember when I said that you might have to do a little bit of maneuvering with the rules of exponents, because that implies that. And that's an essential move in order to be able to turn it into e to the y dy and 3e to the x dx. Let's go ahead and integrate both sides. we're going to get e to the y is equal to 3e to the x plus c, or y is equal to the natural log of 3e to the x plus c. And that would be the general solution of that differential equation. Now let's go ahead and do very quickly 2 additional initial value problems. And then I think that'll kind of bring us to the end of our time on this particular section. So let's do dy dx is equal to -1 over sine y. Okay, and let's do it for y of 3 is equal to pi over 2. Okay. Well, let's go ahead and cross multiply that sine y dy. I'm going to go ahead and put the negative with the sine y, and we'll talk about that here in just a second. Now, that means that when I integrate, I remember that sine y is the derivative of negative cosine. So in order to get back to cosine, I need the negative on here in order to get back to cosine y, and this is going to be x plus c. That means that y is equal to arc cosine x plus c. Now, I would actually not do this right here, because this right here is going to be much easier to plug into. And so cosine of pi over 2 is equal to 3 plus c. Well, cosine of pi over 2 is 0. And therefore 3 plus c is equal to 0. c is equal to -3. And I'm going to have cosine of y is equal to x minus 3. And if I want to, and if I'm actually compelled to, I can go ahead and change that into an explicit equation y in terms of x. And that is the particular solution to that. Okay? Alrighty. Let's go ahead, and I think this will be the last one that we do. So we'll do dy dx is equal to 2x e to the 2y, and that'll be y of 2 is equal to natural log 5 over 2. Well, they've set it up rather nicely for us. This becomes e to the 2y dy is equal to 2x dx. Now when I integrate, I'm just going to have to make sure that I get e to the 2y times 1/2 is equal to that. Okay? Now, the reason that the 1/2 comes in is because, remember, in order to do the chain rule, you would need to drop a 2 in here in order to make it e to the u du, and that would require a 1/2 out in front, and that's just, just rudimentary u substitution. So e to the 2y is equal to 2x squared, and I guess we could call that c2. It's what we're in the habit of doing anyway. So 2y is equal to the natural log of 2x squared plus c2, or y is equal to 1/2 natural log 2x squared plus c2. Now, do you really want to take this and plug it into this form right here? I wouldn't, okay? I would go ahead and plug it into here, okay? So let's sort of bring those two together, and we'll sort of make a little dividing line, and we'll work it out over here. So I know that that's going to be e to the natural log of 5, because the moment that you plug in the output into here, it's going to be multiplied by 2, and that denominator is going to evaporate. 2 squared plus c2. That's going to be 5 over here, and that's 8. And therefore, c2 is equal to -3. And from that substitution, in order to find the particular solution, we recognize the fact that this is the solution to that initial value problem. Okay, well that brings us to a close on our little foray into separable differential equations. I hope that is clear enough. We'll move on into logistical growth here in the next couple of videos, and that ought to round out what you need for the coming test. So email me with any questions. Bye.